Hello, in this video we'll talk about the introduction to Vhdl. In specific, we will talk about behavioral modeling. We'll start with introducing how to program or to write code for the AND gate, the OR gate, the NOT gate, and then a simple Boolean expression. In this video, we'll focus on behavioral modeling. First of all, let's define Vhdl. So Vhdl is a language, and the name is derived from an acronym that is Very High Speed Integrated Circuit Hardware Description Language. So it's a language that describes hardware. A few notes about the language. The language is case insensitive, meaning a lowercase variable, for example, a, is equivalent to uppercase A. These variables are the same in Vhdl. The file name must start with a letter, and it can combine or it can use underscores, numbers, but it cannot contain special characters or a space, or even a dash. Speaking of a dash, to add a comment in the Vhdl language, you can type 2 dashes followed by your comment. So that's how you can write a comment in Vhdl. So for examples, acceptable names for the file name can be and_gate or and then gate. You can capitalize the second word to distinguish it from the first, or you can say and_ then number 4. These are all valid names for describing the AND gate. This name can be used maybe for the 4-input AND. The file extension for a Vhdl file is .vhd. There are two modeling types in Vhdl, the structural and the behavioral. In this video, we'll focus on the behavioral modeling. The behavioral modeling describes the behavior of the circuit, and it can be written usually in one single file and contains operators such as the AND operator, the OR operator, etc. And it may contain statements like the if statement, the while statement, the switch, case, etc. On the other hand, the structural modeling will describe the circuit and the wiring between components. So it will describe the circuit more like a hardware circuit with different blocks connected together. So for that, you will often need more than a single file. You will need to define each of the components first, and then one additional file that's called a wrapper that will declare these components and connect them together, or describe how they're connected together. Logic operators in Vhdl include the NOT, AND, OR, XOR, NAND, NOR, XNOR. So these are the words that describes the operator. You can use them as they are. An example would be Y is equal to not A. So the symbol here is actually the assignment operator. So Y is assigned a value equals to not A. This is the simplest behavioral modeling code. It's the NOT gate code. The name of the file would be not_gate.vhd. Notice how the file name matches the name of the entity here. So let's describe the file part by part. The first 3 lines of code are the library declaration, in which we're just declaring the files or the library files that we will need in this file. The second part of the code describes the entity or the component, meaning we have to put its name, we have to describe its ports, meaning the inputs and the outputs for that component. So the name of the component is the NOT gate. It has 2 ports, one input port named A, one output port named Y. So the keyword to indicate an input is in. std_logic, we use it to describe a single input. So A is an input, that's just one single bit, 1 bit. Y is also an output. Y is also a single bit output. That's why we said std logic. And out because it's an output. Notice how here we used colon because we're defining A, and then we used a semicolon because we're listing the outputs rather than continuing with the inputs. Another colon here because we're defining Y, and the semicolon at the end of the line. This ends the entity declaration. The last part is the architecture part, which describes the relationship between the output and the input to the circuit. And you have to use the syntax architecture. You can give the architecture any name that you want as long as it's a valid name, meaning it has to start with a letter. It cannot contain spaces or a special character. You can use underscore or numbers, but it must start with a letter. And then you have to end behave using the same spelling. Now we're describing the behavior of the NOT gate. By the way, this name can be anything. It's not part of the syntax to use the keyword behave. But I used behave because this is behavioral modeling. So now the architecture of the NOT gate is described as the following. So you have to say the keyword is, then begin, and then this line of code will define y as a function of a. So we said y is assigned a value equals to not a. And don't forget, of course, the semicolon at the end of the line. A few notes on the file. You will see that the name of the entity is repeated 3 times in the file. When you define the entity, and then when you end it, and then when you describe the behavioral of that entity or the architecture of that entity. And it, of course, is equal to the file name as well, not underscore gate.vhdl. So this name must be unique. It must start with a letter, and it must match the file name, and it has to be descriptive. This code describes the NOT gate behavior. That's why we named it NOT gate. Don't forget the semicolons when it's necessary. And don't forget the begin, and it is only needed in the architecture part. The entity part has an is, but it doesn't have begin. Now, in this code, we will see how to describe the AND gate. If you notice, it looks very much the same as the NOT gate syntax. Of course, we had to use a descriptive name, so we named it AND gate. So this is one of the changes we made. The second change we made is that we added a second input because the AND gate takes at least 2 inputs. And then we changed the expression here such that we can describe the AND gate. Y is assigned a value equals to A, and then AND B. Now, given the NOT gate as a template, we can write any behavioral modeling file. So let's do an example. We are given the NOT gate and we want to write the code for a 4-input NAND. Highlighted in green is the name of the entity, and it should be repeated, like we said, 3 times in the file, and it should be also the file name. So I'm going to call it, for example, NAND _4. I will repeat this wherever it's needed. NAND _4. There shouldn't be a space. Okay. And then once again, NAND _4. This will be also the file name, so I'm going to call it NAND _4.py. .vhd. The language is Vhdl, but the file extension is .vhd. So this is the first thing we needed to modify. Next, we have to add extra inputs because the template for the NOT gate only has one input, and the 4-input NAND, of course, will have 4 inputs. So I'm gonna add to the list here, comma, B, comma, C, comma, D. And after that, of course, I'll have the colon as part of the question, as part of the template. A, B, C, and D are all inputs, and they're each a single bit, so I'm going to keep that as it is. I'm going to keep the same name for my output since the question doesn't specify a specific name. So Y is an output that is also 1 bit. Okay. The thing that's highlighted in blue is the name of the architecture. I don't have to change it. It doesn't have to be unique, so I'm going to keep it as it is. But the final thing that I will have to change is this expression. I will replace it with Y is equal to A NAND B NAND C NAND D. And of course, don't forget the semicolon at the end. And this completes our NAND gate or 4-input NAND gate implementation. Now we'll use the same syntax or the same file for the NOT gate that we used earlier, but this time we want to modify it to create a model that describes a logical function, which is f is equal to not k and l or not m. So I'm going to decide to call the file, for example, exp_behave .vhd. X is short for expression underscore behave is short for behavioral modeling. So that means wherever I see not gate, I will replace it with exp underscore behave. Same thing here. I will have to keep the semicolon as it is, of course. And finally, for the third time, exp underscore behave. It's a case insensitive language, so uppercase, lowercase are all equivalent. Now the next step is to see the ports that are needed. We have F as an output. Okay. As inputs, we have K, L, and M. So I'm going to replace A with K, L, M. Colon N, because they're all inputs. They're all a single bit input, so I'll keep standard logic. And for my output, I have a single output labeled F. Colon, it's an output with 1 single bit. Now the last thing we will change is, of course, the relationship between the input and the output in the architecture. So this will be simply F is assigned a value equals to not K. The expression says F is equal to not K and L or not M. So not K and L or not M. Semicolon. Now the expression as it is will still work, but if you prefer to put brackets just to make it more readable, then you can put brackets around the ending first and then around not K. You can add an additional bracket around not K. So we have bracket not K, and then not K is ANDed with L, and then we find not M, then we ORed everything together and assign it to F. What we did so far in this video is we described how we can write behavioral modeling code in Vhdl, but there is an important step that is missing, which is testing our code. So there will be a separate video explaining how we can test our code and how we can read the timing diagrams to verify the accuracy of our work. But in summary, this is the not gate code that we described. The name of the file is optional, but again, it has to follow certain guidelines. We're going to assume we will use not_gate for the not gate. For the AND gate code, here as a comment, I added my name. Remember, 2 dashes is for the name, for adding comments in VHDL. Here I added another comment stating that this is the AND gate. Next is the OR gate code. Again, I named the file or_gate.vhd. It has to match the name of the entity, but any valid name can work as long as your testing code assumes the exact same name. Finally, this is the expression that we did, and it will describe f is equal to not k and l or not m. This is all there is in this video, but again, before we finalize our work, we have to test it, and there will be a separate video on how to test our code.